My name's Matt, and I will be talking with Frank Schmid about adopting low-code to modernize workflows, integrating AI smartly, and applying economic ideas to make better tech and business decisions.
So, Generative is a company. I think they are more than 100 years on the market, which is quite a some time in the insurance business. But maybe you could introduce yourself and tell to the listeners a few words about yourself and your experience.
Yeah, thank you, Matt. It's a pleasure to be with you. My name is Frank Schmid. I'm actually a trained economist. I received my education in Germany, and my first position was at the University of Vienna, Austria, and I was an assistant professor for financial services. And then I moved to the United States to spend time at the Wharton School of the University of Pennsylvania in finance. My first job in the United States was a research economist position at the St. Louis Fed, and at some point I thought I'd take my skills to the private sector. I joined the insurance industry, spent a number of years at AIG in the financial district of New York City, and since August 2020, I'm with Generative, leading the IT department, which I had not done before, and we can talk about that. Generative is a reinsurer, as you said, Matt. We have a long history. Actually, our German subsidiary is even older. It's the old Cologne Re, which we acquired at some point. And we are a member of the Berkshire Hathaway family of insurers and reinsurers. So, and again, I'm happy to be with you, Matt.
Great, Frank. Thank you for the introduction. And you already mentioned a topic that I wanted to discuss with you. I mean, the transition to the role of the CDO, right? You have the background in economics, the background like you work as a leader in AIG, for instance, but more on a, let's say, economic side. And why did you choose to step into the CTO position?
Yeah, thank you, Matt. That's a good question. Now, I've become increasingly interested in technology in the years prior to taking the position. And that's because there's an interesting confluence happening here between, information technology and quantification. And given my background as a quantitative economist, as an econometrician, that's a fascinating development. So on the information technology side, right, we have observed the rise of software over the past couple of decades, right? In the past, when you thought information technology, it was about hardware, right? It was the mainframe, then client-server computing. And when you look at the IT budget, right, it was largely fixed costs because hardware generates fixed costs. And now you had the rise of software. You had the arrival of the internet and the cloud. And suddenly, an increasing share of your IT budget is actually variable costs. So this transition from hardware to software, I find fascinating. And then on the quantification side, there was the arrival of machine learning. And I'm a trained econometrician, so I was trained to take hypothesized social and economic relations and cast them into a set of equations and then estimate the parameters and generate predictions. And now machine learning arrived, right? And machine learning does not know about social and economic relations, right? It makes predictions purely based on relations in the data. And these predictions tend to outperform the predictions of structural models. So that is a fascinating development. And when you think of AI, which we will talk about in a bit, right? You see that confluence of software and hardware and quantification techniques. And so from that perspective, 2012 right? AlexNet, when AlexNet won the ImageNet competition, that was a watershed moment, right? So the arrival of deep learning, which takes us beyond the manual feature engineering and machine learning that I also used to do. And, it has deep learning comes with feature learning. So you have, and it was the first model and ImageNet that actually ran on NVIDIA chips and its CUDA software. So you have this confluence of quantification techniques, meaning deep learning of hardware, the NVIDIA chip, and software, the CUDA software layer on the NVIDIA chip. So these are clearly exciting time for anybody who is interested in quantification.
So speaking of your role as a CTO, so because of the background, so you don't have the technical background, like a pure technical background, but I'm just wondering, like, how do you approach your job? Like, how do you approach your job? Because at the same time, I think it could be you can have the advantage of this out of the box perspective, right? But in some cases, of course, there are disadvantages. So I'm interested, like, how do you approach?
Yeah, thank you, Matt. Good question. It's clearly a challenge to take over an IT department without having worked in IT before, not being an engineer. And there's a certain way of thinking, right, in engineering. So it's clearly helpful that I have a theoretical background in economics and that I have spent time on the business side at AIG. And so without theory, one cannot abstract and conceptualize. And in my 4 years in technology, I have found the ability to conceptualize and to abstract is the scarcest skill. And having spent time on the business side, that does help understanding, how an organization works and what the priorities of the organization is. Now, as a leader in general, there are two tasks one has to perform when assuming a leadership position. One is to establish principles of decision-making for the team. And clearly not being an engineer myself, that was even more important. And secondly, quickly learn, where to augment and complement the skills of your individual team members. And so I established those principles and I lead by these principles with a fair amount of attention, frankly, to detail and execution. Now, attention to detail is not the same as micromanaging, right? Because it's not interventionist. But not being an engineer, I have to rely heavily on those principles. And I can talk about the 5 principles that I have established a little bit. First, openness, right? So we prefer open systems. For instance, like systems that integrate or provide integration. An example is open file format. That is important in our data architecture. Systems that scale, the cloud as an example, systems that are exposed to competition and benefit from the contribution of the many, and that's open source code. So just to give you those 3 as examples. So openness creates optionality, which is figures prominently in our thinking, optionality, and it also ensures continuing progress, right? Through exposure to external forces, because an open system is exposed to external forces by definition. Another concept that we favor is modularity. So we prefer systems that allow us to break down a complex problem into a set of small, simpler problems. And interestingly, you see that in a bunch of spaces. For instance, machine learning, right, is established in this way. You have a complex problem, you just break it down in a large set of small, simple problems that you can solve. And the architecture of the NVIDIA chip is like that. So you see that concept of modularity pop up in information technology a great deal, and we like it because it in terms of architecture, it allows for parallel processing. You can address modernization or workflow redesign in a modular way. But modularity also gives you optionality in sequencing. So you can actually, break it up also on the timeline, not only and architecture-wise in parallel processing. So, and that reduces clearly execution risk. And so it gives us this option of like local optimization when you think mathematically, right? You can optimize locally, and you can incorporate technological progress in individual modules, individual workflow components, independent of other components, right? Other modules. And the third of the 5 is, we like platforms. Right, so we do prefer platforms over best-in-breed tools. It matters a great deal, for instance, in security, but also in other areas. So we like platforms because they are a manifestation of openness, right? Whereas best-in-breed tools frequently are just point solutions. And so platforms offer the opportunity for standardization, for the creation of libraries of reusable components. But most importantly, right, platforms generate network effects. So if you add a module to a platform, it increases the value of every module that's already on the platform. So that's the definition of network effects. And so I actually mentioned 3 embodiments of scale here, right, in the context of platforms, which, is arguably the most powerful force in technology. And then the 4th is composability. So if you take openness and modularity and put them together, right, you have composability. So for every existing firm, and Matt, you mentioned, right, we have been around for a while, so we have a fairly diverse technology stack. And so composability matters a great deal. So it matters anyway, but when you have legacy technology, then it matters even more. So we like the orchestration capabilities of our low-code platform, right? So that generates a fair amount of composability. And also, again, you have the network effect here, meaning, every component you add actually adds value to every existing component. And finally, there is reversibility. Now, that's a term you don't hear a lot in technology, and it actually originates in real options evaluation, which, in the 1990s was a fairly prominent concept. It has fallen out of favor maybe a little bit, but it matters a great deal for us, and I can speak to why it matters a great deal in the AI adoption process. So real options as opposed to financial options, right? They exist where you have learning and irreversibility both. And irreversibility is highly related to the concepts of stranded assets and sunk costs. So, and when you have real options, and they always exist, the question is how material are they, right? And so they originate in learning and irreversibility both, and they mean that the net present value rule, which is, your traditional decision rule for projects, is incomplete. So now learning always exists, right? I mean, the future is uncertain, so you have technological progress, and frequently it's not predictable. And also your environment may change, right? The macroeconomic conditions may change, inflation, recession, An organization's market environment may change. So there's always that learning, right? As time progresses, we learn. And then there's irreversibility, and that comes in two flavors, interestingly. For one, right, the decision not to execute a project is always irreversible, right? Because the project may have created options at a future point in time for future technology decisions that are now not available if you don't get going. So follow-on projects are an example. So that generates what is called the cost of waiting, right? So, and the cost of waiting adds to the traditional net present value rule, right? So actually the cost of waiting incentivizes you to move faster than at the traditional net present value rule. And then again, right, I mean, executing today could also be a regret. So, if you get going on a project, it could turn out to be a poor decision in hindsight, right? And then negotiations might, want to change course or, terminate a project or alter a project. And so that may create what is called stranded assets, so assets that are not portable to an alternative project or an altered project. And so there are costs that cannot be recovered. And that generates the value of waiting. So there's actually value not to move forward because of that risk, right? And so it subtracts the net present value from the net present value rule. So it actually incentivizes you to move slower than a net present value rule. So now how do we deal with that, right? You can do the math, but typically we don't actually write down the numbers. Of real options. So what we do is we just establish two principles here to address those two aspects. One is, the cost of waiting and the value of waiting. And the cost of waiting we address by favoring technology choices that increase the option set available, and for the future. And then the value of waiting we address by favoring technology that's highly reversible, right? Because if you have no reversibility, if you have no irreversibility, so complete reversibility, real options wouldn't exist, right? The challenge is addressed. So if you make technology choices that are highly reversible, then you address an important aspect here. So that concept really does figure prominently, and it plays a significant role in the AI adoption process because that's like an iterative process, right? Organizations are on a discovery journey, right? And we don't know exactly how the technology will evolve, and we all have to figure out how to put it to productive use. So there's an interesting concept in machine learning. It's called the greedy choice property. And, ideally your tech stack would satisfy this property, but of course it does not. But it's kind of good to keep it in mind because, the ideal tech stack essentially would be one where, you would have that satisfies the greedy choice property. So that means that you can arrive at a globally optimal solution via local optimal choices, right? And so if at every step you can optimize without having to go back to the previous step and revise that decision, then, your optimization problem follows the greedy choice property. I mention it because, talking about the connect between technology and machine learning, and the greedy choice property clearly figures prominently in machine learning.
You mentioned the state of the economy and how this impacts decision making, and I think you are one of the best person with whom I talk to tell me more about your views, your assumption for 2022. Like, how do you see the economic outlook last 2 years, especially in tech, they were really turbulent, I would say. And like now S&P is going like crazy when you look, especially relates to all the AI companies, right? How do you see it?
Yeah, Matt, they say that economists are people who have predicted 5 of the past 3 recessions or so. So I'm actually in the camp of arguing there is fairly limited predictability in human existence and in the economy overall. Now, I'm always optimistic about the future because optimism is a manifestation of positivity. And positive thinking is an important quality of a leader. Now, optimism isn't blind to challenges though, right? So as a baseline, it's good to think of the economy as a random walk. And I'm a big fan of the random walk. So the random walk means tomorrow will look like today, plus an innovation. And an innovation is a change that is permanent, right? That puts you on a new level. And we know from the normal distribution, small innovations are more likely than large innovations. And, the random walk is its own forecasting model, right? Tomorrow will look like today. And frankly, many processes in economics, be it economic growth or inflation, are very close to a random walk. So there is just limited predictability, I would say, in changes, right? And the best forecast many times is tomorrow will look like today. Now, there is also mean reversion, right? So especially like following shocks, right? Mean reversion following shocks. So for instance, economic activity, recovers from a recession, the stock market recovers from a crash, and central banks do have the power to bring down the rate of inflation, right? So these are mean reverting processes. But unless you experience the shock, and you are in such a that you are in a mean reverting process, the random walk is a good predictor. Now, returning to mean reversion, the challenge is, right, for instance, the time to recovery from an economic recession can vary greatly, right? And so there is a fair amount of uncertainty, even if there is a mean reverting process playing out. And secondly, the shock itself that generated a mean reverting process, right? A recession, for instance, or an inflationary shock, right? The surprise inflation we just experienced, that is not predictable, right? So you have returning to the random walk, and frankly, unless you are in such a post-shock environment, the random walk is a good predictor. However, this being said, not that I want to qualify it, I think there are two economic variables that I think I was paying attention to. One is clearly the rate of inflation, and Matt, you mentioned how the world is changing, right? So there is research that shows that the rate of inflation is a function of central bank independence. Now, central banks have done quite a good job in anchoring inflation expectations around the world. With the concept of inflation targeting first implemented in New Zealand. Now, the Fed was fairly late, right? Formally, inflation targeting was adopted in 2012. Inflation expectations are well anchored. Should they become unmoored, then we may return to higher and more volatile inflation rates that we experienced before the concept was adopted. And then there is the yield of the 10-year Treasury security. So the United States is the safe asset provider to the world, and the 10-year Treasury security is a benchmark for the global financial system, right? The Treasury market is the bedrock of the global financial system. So So now we have seen a sharp rise in federal debt held by the public in the United States and in other countries, Germany being an exception. And there is, we know that the fiscal path of the United States is unsustainable if you believe the Congressional Budget Office, which is bipartisan. So I think that's worth watching. There will be changes here given the unsustainability of the fiscal path, and the 10-year Treasury security plays a very important role in the soundness and safety of the world financial system.
And speaking of the insurance industry, the state of the insurance industry, I would say from the perspective of technical challenges, what are some, like the biggest technical challenges facing the insurance industry right now?
Well, from a technological perspective, Matt, I'm not sure there's anything unique to the insurance industry. I think outside of technology, right, you see climate change, for instance, does play a role, predictability of losses, insurance losses, etc., wildfires, convective storms, etc. So there are clearly those challenges, but from a technological perspective, I don't see anything unique to the insurance industry. Now, it's really the AI adoption process, right, that we all are looking at. Now, clearly, some use cases in generative AI are more relevant to insurers and reinsurers and than other industries. And the ingestion of unstructured data in underwriting and claims is clearly an example of a key use case for the insurance industry. Now, at the conceptual level, we deal with technical debt, right, associated with legacy technology, and technical debt is called technical debt because it's a liability, and it constrains your option set and technology decisions that are available to you. And but again, this is also not unique to the industry. It's interesting that I feel technology is increasingly lexicographic. So meaning you cannot have B without A and you cannot have C without B. So the way I think about it, without the cloud, you can't have a modern data architecture. And without a cloud-based architecture, there is no deployment of AI at scale in your organization. So, and then, if you have data that's locked up in legacy applications, well, that then imposes, a binding constraint, right, in the productive use of generative AI. Now, technical debt also manifests itself in operational risk. Technologists tend not to talk too much about security, but it does matter. Legacy technology figures prominently, right, and security risks, especially when it comes to edge infrastructure and external facing applications. So I'd like to point out the security aspect of legacy technology, which again, not unique to insurance, but it does matter, especially for consumer facing insurers.
And last time we had a really interesting conversation regarding the low-code platforms. And you mentioned that you have built a lot of IT systems or the applications inside the organization with the low-code solutions. And this is quite unique and interesting topic. Maybe you could tell us more about the use cases and how has it been working for you using the low-code platforms?
Yeah, thank you, Matt. Well, we came to low-code similar to others, right? We thought, well, we have legacy technology and the low-code helps us remediate legacy technology challenges. And that brought us to low-code, and it does play a role, but we realized that the opportunities associated with low code are much greater than that. So yeah, we use it for the elimination of our legacy technology and workflows, workflow components. So we also build workflow components using low code, and overall the big picture really is to use low code for workflow orchestration. Now, when I say workflow, I mean business workflow. I don't mean software development workflow, right? So we're also building our first complex data intensive and external facing application using low code, but it's not so much application oriented, I was thinking. It's much more workflow oriented, which means business driven. So we have, given our size and the way we are set up, so we have a single dedicated team for low code development, and that resides within IT. So we don't pursue the citizen developer model, and we keep this team lean. The reason is we want to further interaction with external parties for diversity of thought, but also knowledge transfer, right? And it ties into the concept of openness, right? So we draw on the low-code vendor itself when it comes to resources, and also the partners, within the ecosystem of the low-code vendor, especially when it comes to matters of conceptualization and architecture, right? And then we leverage the ecosystem also for staff augmentation. Clearly, so the bigger a project, the greater that ratio of external to internal resources. But it's important to see that there's the internal team which we keep small. We force it to interact with external parties. There's their resources made available by the low-code vendor itself, and then the ecosystem. So diversity of thought, knowledge transfer, these two concepts do play an important role. Now, our customers are the business units and corporate functions. So we are a reinsurer, so it's business to business. We are not consumer facing. And from an IT perspective, it's really the business and corporate functions that we serve. And over the past 3 years, we have built a fair, number of workflow solutions, especially for legal, actually, and the finance function. So it's either that we did a lift and shift, away from a legacy technology to low code. Sometimes lift and shift is okay. You can iterate later. Then we also consolidated legacy components into, single low code workflow solutions. Or we that's the third one. We actually developed low code solutions, again, workflow that was previously manual, right? And manual means there are handoffs, there's potential source of error, etc. So, and now our organization has a fairly high ratio of complexity to size, and in part because reinsurance business itself is complex, and secondly, it's actually a small industry. So we offer reinsurance globally. We operate in many countries, and we offer in all continents, and we offer both property and casualty in life and health. And you can imagine life and health, you have personally identifiable information, and you have data aspects that you wouldn't have in property casualty. So and so, given that the industry is small, there is a dearth of off-the-shelf solutions. So there's a fair amount of building as opposed to off-the-shelf usage and reinsurance. And low code is clearly ideal.
And let's say we have the low code and we have the so-called like a pro code, right? Like the solution when they're built. And you have like a custom software here that you write. And can you share a bit of a perspective here on the balance between the pro code that you have and the low code solutions? Maybe some trade-offs. How do you decide if you go the direction low code with the new application, or you use like a more custom software development approach?
Yeah, internally, we don't have pro code development talent. So when I started, we had actually outsourced all software development. And so we decided to rebuild development capabilities, but only in low code. Now, we have in the past built an application using pro code in the business. And of course, there was then an external party building that application. It's as you say, custom built through insurance. It has its justification. At the same time, another project in the same space we are now doing using low code. That's the one I mentioned. Fairly complex, external facing, data intensive. Now, interestingly, low code is the younger technology, and so when you have a new technology, there's an adoption process, right? And this adoption process takes a long time. So the question is then, has this adoption process really come to an end? Are we in a steady state as far as that balance is concerned that you mentioned, Matt, between low code and pro code? Or are we still, in this low code adoption process, right? Because a new technology requires different thinking, different skill set, right? It's a discovery process, but also a skill building process. So that's a question. There are a couple of things that speak for low code. I mean, first of all, it reduces the scarcity of development talent, right? That's an obvious one. Secondly, it does generate network effects. I mean, I already spoke about the reusable components, right? The libraries. And then it does also actually another benefit that's not mentioned a lot is actually on the security side. So with pro code, you have to do a fair amount of code review, more than you have to do with low code. With low code, you can take a platform approach from a security perspective. So that's another reason why we actually prefer low code over pro code. But ultimately, right, there is a balance here. It's just that the question is, how far into the adoption process are we? And is low code already fully leveraged? Or do we still have some way to go here? Now, of course, the question comes up, right, that now that we're told that English is the hottest new programming language, right? Does this benefit low code more or pro code, right? I do get this question and I hear it at conferences. I can speak to it. I don't know. It's probably benefits both, right? Pro code and low code, but how it will tip the scales, I have no answer to.
And I see clearly that you are passionate about the AI and the impact of the AI on the technological part of the industry. And I'm wondering, what is the impact of the generative AI on the insurance industry? Do you already see some disruptions, or maybe you introduce some kind of solutions around it?
Yeah, man, that's a good point. Thank you for bringing that up. Yes, I'm passionate about it. I like to compare it to electricity. So generative AI, we look at it as general purpose technology. And general purpose technology has, three properties. One is it is pervasive, so it shows up everywhere. Look at electricity, and the same you will see with generative AI. And it's really the generative aspect of AI. So think of November 30th, 2022 as the arrival date of generative AI. That's the release of ChatGPT, right? The arrival of generative AI in what is called the application sector. So that's us, right? We apply this technology. That brings me to the second property, which means the general purpose technology is capable of ongoing technological improvement. Now, when you think of electricity, right, the first battery was built at around 1800. It took a long time for the light bulb to arrive, and then, the alternating current electric motor in 1890 around. So, it took decades, right, for the technology to advance. But that's the hallmark of a general purpose technology. It's capable of ongoing improvement for decades. And secondly, general purpose technology spawns co-innovation and co-investment in the application sector. So be it insurance or, any other industry. Now, if you take the two things together, ongoing technological improvement for decades and the co-invention process in the application sector, so at the level of the insurer, then, you will conclude that it will be like a feedback loop playing out over decades. So that the adoption process will take a long time. And I think that we should keep that in mind. It brings us back to what we discussed before, like reversibility and modularity and things like that. So now, of course, when a new general purpose technology arrives, and again, there were not many, like following electricity and the electric motor, right? There was the semiconductor, for instance, and before electricity was the steam engine. So there are not that many, and they are clearly highly transformative. Now, of course, when such general purpose technology arrives, then there's some automation anxiety takes hold in society, right? And there's this fear of widespread job losses. Now, clearly, a general purpose technology gives rise to automation and hence, automation anxiety in society. But automation has two aspects, right? I mean, one is the substitution of labor, and the other one is what is called augmentation of labor. So the enhancing and complementing of human skills. And substitution of labor, like it's one-off, right? It's a steady concept. You substitute labor, you have a productivity gain, that's it, right? Whereas augmentation of labor, so the enhancing and complementing of human skills, this is an ongoing process, right? It's a dynamic process. It plays out during this entire adoption cycle. And historically, if you look at the productivity gains that a general purpose technology has delivered, it's absolutely, substitution of labor is dwarfed by augmentation of labor. And the result is that human labor is much more valuable today than it was, at the dawn of the Industrial Revolution 250 years ago. So first, we still all have jobs, and secondly, these jobs pay well. So all the technological progress that we have experienced over the past 250 years have actually made human labor more valuable, not less valuable. So that's to be kept in mind. So what will happen in this generative AI adoption process? Well, looks similar, will resemble what will happen in the economy at large in other industries. So the way I look at it, there are three levels of adoption. One is a task level improvement. So all the co-pilots that we now have, right? Task level improvement. A given task can be done in a better way. There's some productivity gain. The co-invention effort is not that great, not that it's not that hard to do, but the productivity gains are also not that great. But then the next level of adoption is workflow redesign, and this is where you will see meaningful productivity gains. Now that takes greater co-invention effort, and you heard me talk about workflow quite a bit in this session, but also the productivity gains will be much greater. So greater co-invention effort, greater productivity gains. And then the third one, and it may take some time for this to arrive, is organizational redesign. So task level improvement, workflow redesign, organizational redesign. Now, the poster child of organizational redesign is really Amazon. When the internet came along and Amazon reinvented a bookstore, right? It was not task level improvement. It was not workflow redesign. It was really organizational redesign. Took some time to arrive. Great co-invention effort, but also, of course, tremendous productivity gain. So that's the journey, right? And there's clearly a timeline here as well, right? Workflow redesign takes longer. Organizational redesign takes longer. And organizational redesign may come from the outside. It may not, it could be a change in the business model, the way we do insurance. We don't know. But it's interesting to see that clearly Amazon or, Tesla, the electric car, these were innovations that came from the outside, not, were not born in the legacy industry, right?
And let's maybe connect now the two things together. I mean, you mentioned, we talk about the low code, we talk about the AI, and I think today there's a lot of proof of concept in the area of AI. This is like a fresh topic, fresh approach, maybe like not fresh topic, but a fresh approach. Like we have a completely different approach that we had like a few years ago, and it's way more faster to create some kind of proof of concept. And there are tools that are, released on the market pretty fast. That like disruption is extremely fast nowadays, thanks to that. And I'm just wondering, do you use the low-code solutions to build the AI proof of concept, or do you go maybe more of a custom build? Do you have a more custom build approach with the pro code as we call it?
Yeah, we rely heavily on functionalities provided by our hyperscaler, our cloud service provider, and if you look at these functionalities, they're quite powerful. And building an AI system is essentially, for us, it's about orchestrating these functionalities. And so we have a fair amount of AI in our organization, and we are quite disciplined, right? It all comes from our hyperscaler, and we try to be really disciplined here. So it's all about orchestration. If you want to get something going in generative AI, it's a fair amount of engineering, right? It sits in your data architecture. You have to have your foundations in place, and then all the AI and cloud engineering that comes with that. So for us, it's a matter of orchestration. This is how we look at it, and making it part of the workflow. Now, we use low code also in this context. I give you a small example, right? If you took Azure OpenAI Studio and the chat capabilities there is no safety prompt, right? Meaning, that from a governance perspective, you would have to manually put in your safety prompt that guides the behavior of the model. So we use our low-code platforms. We build a chat functionality, an interface and a wrapper, if you will, a wrapper around Azure OpenAI Studio. And so the safety prompt is hard-coded and it's visible to the user, but it's hard-coded, so it cannot be changed. Now, that's a matter of governance, for instance, but it's just a small example, right, of orchestration and the role low-code can play, of course. It's just a small example, but overall, again, it's really about orchestration and inserting it into existing workflow or maybe redesigning workflow, right? And do this in a modular way.
And last but not least is the question that I ask all of my guests. And Frank, can you recommend any books and resources that have had a major influence on you as a tech leader?
Yeah, thank you, Matt. That's actually easy to answer. There are two books that heavily influenced me over decades, in fact. One is Hagakure, the Code of the Samurai. That's the most influential book when it comes to leadership, but also Leo Tolstoy's War and Peace. I appreciate this book as a study of the role of randomness in human experience. It gets us back to the random walk. And I also value the essay by Isaac Berlin called The Hedgehog and the Fox, which, gives us a valuable introduction to Tolstoy's view of history. And, it's fascinating space. What is the role of individuals versus, the historical process that plays out overall. And then on the lighter side, but I think quite useful when it comes to leadership, is actually Robert Aldrich's 1965 movie, The Flight of the Phoenix, which is just a great movie and a great study of, human behavior and exigent circumstances and how you can think about the situation and the decisions that you derive, in such an environment. So.
Frank, thank you so much for really insightful discussion here today. I really appreciate your time and your views here. And wish you all the best in, reinventing and disrupting the insurance industry.
Right. Thank you very much, man. It was a pleasure to be with you.
Take care.
Follow Matt and Leszek on LinkedIn.